Ahoy! Vítejte. Jmenuji se Dan Galpin. Nemluvím česky, so this will all be in English. So we've got a small crowd for one of my favorite topics, which is coding to the metal, developing with the Android NDK. Now, let me get a poll in the audience. How many people here have Android phones? All right. Now, how many of you play games on your Android phone? You can raise. You don't be shy. It's not a bad thing. You're among friends here. We're at a Google Developer Day. So what I do is work with game developers to bring the best games to the Android market. And part of the way I do that is by helping game developers use the Android NDK. And this is my Twitter, by the way. So before I begin, I'm going to put this up. This is just the QR code that points back to the mobile site. If you're not already gone to the Google Developer Day mobile website, please do. It's pretty awesome. They've done a great job of putting it together. And you can leave feedback about this session or about any other session or anything about today. So please do. We want to know whether we're wasting your time. We want to know whether you're wasting our time, all of these things. So it's important that when we talk to you, that you're getting the information that you need. So please go, let us know. So, native code. Why would you use native code on Android? Well, one is it turns out not everyone codes in Java. There are other programming languages out there. C and C++, there is tons and tons of code out there, and people want to bring it to Android, and they don't want to have to rewrite it. Because the #1 thing any programmer should be is lazy. If you have code that works, don't rewrite it just because you're going to a new platform. Also, performance. There are lots of tasks in which it just doesn't make sense to go and use a virtual machine like Dalvik. Now, we added support for OpenGL2 in Android 2.1, but we did that only through the NDK. In Froyo, you can actually get to it. In Android 2.2, you can actually get through it to that same OpenGL2 in Java. But if you want to get to it in Eclair, you have to use the NDK. And finally, we allow you to get access to a lot more memory for your application if you're going through the NDK. You aren't bound by the size of the Java VM. You have the power to make the Android architecture system shut down all of the other applications on the phone to give your application memory. So with great power comes great responsibility. And so you can do this. It's not the way to make your users happy, but you can. And you can write applications that are very, very powerful in native code. So why would you not use native code? Well, we give you these great UI frameworks. You can't get to them from native code. So your application won't look or behave Android-y, to use it as an adjective. And it's very difficult to do that through using the NDK. And it's a lot easier. We give much, much better tools. I know that people don't always think the tools we have are the best, but trust me, they're way better than the tools we give for the NDK. So what do you get with the NDK? You get libc. You get a little bit of C++. Oh, I should mention, before I continue on, all of these droid icons that are part of this presentation were actually drawn on a whiteboard in Building 44 in Mountain View by one of the members of the Android team. And I just saw him drawing these there one day, and I said, oh, that's so cool. Can I use them in my presentation? And so I went and I took an Android phone, and I took a picture of the whiteboard, and I put all of them into GIMP and processed them and made them the right colors for this presentation and colored them in. So if you don't like the coloring, that's all me. So to go back, now I digress. You get logging, you get a little bit of threading, zlib compression, as I said, OpenGL, and JNI graphics. Now I'm going to put some of these up during the presentation. These are only good for one person, so whoever manages to capture this first gets the 10 points. So I'm going to throw a few of these in here. And if you didn't get it, that's OK. A bit of what's missing. Here's what you don't get in the NDK. You don't get application lifecycle events, input or sensor, resources, a lot of networking, sound, media processing, and text input. And there's more, but this is like the basics of what's missing. So if you look at this Android architecture slide, which is pretty famous, you've seen it on the website. It looks kind of like this. I've cleaned it up. This is actually what you end up getting with the NDK. So all that stuff with applications and frameworks and libraries, you can't get to it unless you use JNI. So from the NDK, this is it. You get some libc, you get some OpenGLES, and there are a few other things I talked about that are in there too. So let's talk about the activity lifecycle. Now, how many of you are Android programmers, have programmed a significant amount in Android using the regular SDK? Show of hands? OK, so this is going to be a review for a lot of you. But here's the thing. With the regular Android application, the framework helps you handle the activity lifecycle. But with the NDK, it doesn't really help you at all. So you really have to know this. If you thought you knew the activity lifecycle with a regular application, you still probably should look it over if you're writing NDK. Because all of this stuff, what happens when your application gets restarted and stopped, and when other applications need memory and you get killed off, all this stuff is much more important when you're working in the NDK because the framework does not help you out. On pause is even more critical in the NDK than it is in a regular app, because it is your only chance to save yourself and to make the app work correctly in Android, to pause the threads, to cancel your sound, and to save critical data. And you have to do it really quickly because you're running in the foreground. And there's nothing that users hate more than anything than to have their application, their phone, stop while something else happens. So you've got to be quick. And if you're not quick enough, the Android framework will kill you off. So other states to think about. On stop, the good news is you're not in the foreground anymore, so you can do a lot more. The bad news is Android may decide not to call it. On restart, on start, on resume, on create, on destroy. All of these things are useful. Just remember, they're not guaranteed to be called, but they're nice. You can do nice cleanup. You can remove, you can unload memory. You can stop your threads if you have anything left. And the good news is the smaller you make your application in these other states, the better chance you have of surviving and having Android not kill your application off. So these are useful. And remember, you can still use onSave instance state to save your user interface state, even if you're coming from NDK. You can just take a byte array, pass it right in there. It works just fine. Input and sensor events. You don't get these in the NDK. And I recommend actually using all of the key messages because they do some smart stuff for you. If you have a device that has got capacitive buttons, like not real buttons on them, these things will help make them work better. They try to do things like detect when the user takes their finger and slides it into the button area. If you use the low-level onDispatch key method, you won't get that support. So it is worth actually passing all of these events. Touch events, trackball events, and sensor events. All you have to do from JNI. You don't get any assets or resources from NDK. So all of your localization, anytime you need to get to things like bitmaps or textures, all of that stuff, you're going to have to do yourself. So how many of you out there consider yourself to be hardcore programmers? Oh, come on. Not single one of you considers yourself. I mean, look, I am here. Half of my family is from the Czech Republic. I want you to know this, OK? We're the Kushkas and the Hrodas, OK? I'm here in what I consider to be my second homeland, and there is not one hardcore programmer in the audience here. Well, if this is NDK is a place for hardcore programmers. Now, you don't have to be one. It's not hard necessarily, but it's definitely it doesn't coddle you or help you as much as when you're in the Java environment. Sound. Now, as most people know, you've got 3 different kinds of sound in Android. None of them are directly available from the NDK. But what's cool is that NDK gives you the power to really use audio track. because audio track allows you to mix your own audio and send it raw right to the sound card. So a lot of people are doing this with native games. You just don't have the performance to do this very well when you're running in Dalvik. You also have Media Player, which allows you to do things like play OGG Vorbis or MP3 or AAC files, and Sound Pool, which you use to queue up a whole bunch of small sounds into memory so that you can shoot them off quickly with low latency. So the native solution, and this is really where the crux of things is. This is what you're going to have to do to make use of the NDK. You're going to call from Dalvik into native code to support your activity lifecycle. You're going to call from native code into Dalvik to do things like event processing and sensors. And the reason I suggest this, you don't have to do it that way, but the reason I suggest this is you can take advantage of all the cool queuing stuff that we have built into the framework. But again, you can pass the events straight through and queue them up inside of your code, either way. For user interface calls, you also are going to call from native code into Dalvik, but I recommend wrapping them up in messages. And the reason why is that Android's user interface is ultimately single-threaded. So if you try to call a bunch of user interface calls from another thread, you're going to find that the system is going to get very unhappy, and it's not going to do what you wanted it to do. And then finally, if you want really high performance, you can actually use native code to directly open the APK. And I'm going to talk a little bit about how to do that in the next couple of slides. So, more of the native solution. Use GL Surface U. Now, I'm going to talk a lot about OpenGL in this session. Why? Because it's the only way you can build up user interface inside of the NDK directly without going into JNI. Use the input method manager to show a soft keyboard. This is really useful. Some people go and they write their own soft keyboard when they're doing native code. Not necessary. One command, you can bring it up. You can make use of it. You end up getting keystrokes back from it, just like if it was a physical keyboard. For high-level networking, you're kind of on your own. You can use what we have built in. It's nice because we do things like secure sockets, which are one of the things that are not available from the NDK. But you can also port whatever library you want over, and people have done this. And finally, definitely use JNI to work with third-party libraries like Facebook Connect and to create intents and to launch URLs. Oh yeah, 10 more points. And a chance for me to get a drink of water. Remember, only the first person gets this, so. All right. So if this is your standard Android application, you got the framework, you've got some activities, each activity has a view hierarchy, maybe you have an extension class out there, then this is what your NDK Android application is going to look like. In other words, the vast majority of your code may still end up, in terms of classes, may still end up sitting in the Java side. But you can actually, believe it or not, do a lot with the NDK. So how do we build native code? Well, you're going to want to make a JNI directory. That's where all your native code is going to sit. It's also the location of the make files. So here's what it looks like. You've got android.mk, which uses standard makefile syntax. You're going to put all of your source code, and it's also going to be where you define the name of your library, which turns into libraries that get built in these libs directories. It's very nice. You don't have to use NDK build, but it does a lot of things for you. I definitely recommend doing it starting out. Application.make gives other flags, typically, to the build system. In this case, it's saying build for both ARM5 and ARM7. One of the cool things we added in NDK R4 is support for ARM7. This means you get hardware support for floating point. It's a lot faster on the devices that can support it, and best of all, it adds 0 additional work if you use NDK build. You simply specify that you want it to build 2 binaries. Both will get built, put into library directories for you, and the phone will automatically choose the correct one. So it's very, very easy to do this. Now, if you want to use ARM Neon, that is also supported in the NDK, but you're going to have to detect for the presence of Neon yourself. And not all ARM7 devices are guaranteed to have Neon. So it's definitely something we provide, something called CPUFeatures.c, which we include with the NDK, which shows how to detect for Neon. Definitely make sure you have a non-Neon code path. because devices like Tegra 2 do not support Neon. Oh, and yes, as you can see, when you specify these, those are the libraries that get built. So the manifest is still important if you're running native code. Why? Because the protection scheme is still the same as it is when you're running Android. You still have to say, oh, well, there's two things. Let me first talk about that the NDK build actually is going to read your manifest. So that's important because it's trying to be smart. It knows that if you're setting your application to being debuggable, that you might actually want to run it in a debugger, and it's automatically going to turn optimizations off for you, so you have a chance, maybe, of the debugger hitting one of your breakpoints. Secondly, permissions are still important inside of manifests. If you try to talk to the internet and you do not have the internet permission, it's not going to work. It's simply going to give you an error. So even though you're not using the Java classes, you still have to use these permissions. This is how Android does things. So calling native code is pretty easy. I'm taking this from an example that ships with the NDK called Plasma. And it uses a new feature which is in Froyo called NDK bitmap that I talked about a little bit before. So we have a function on our class file that's declared with the native keyword. We then run Java H, which is a tool that comes with the JDK, and it automatically is going to generate a header file for us with this fun syntax, which contains the return value, the class name, the method name, the JNI context, which is really important. This is how we do all of the calls from within native code into Java. And it's important that every single thread has its own JNI context. You cannot create a new thread and pass this in and expect it to work. I'll talk a little bit about that later. Your class object. Now notice that this is not a class. So this is an object. If you want to use reflection to call functions within this object, you're still going to have to get the reference to the class. But fortunately, there's a JNI function that does that. Finally, our parameters. So calling Dalvik code is pretty easy. This is how you call code from within Java. And in fact, you can call anything within the class library if you can get a reference to it. So here's how we do that. There's a wonderful tool called Java P. And what Java P does is it prints out all of the functions from within a class file. And if you use the -s flag, it'll actually give you the function signatures, which are these weird things with like ZV in them. And you can optionally just figure them out, but there's a tool that does it. So I say you might as well use it. Then all you have to do is use find class within your code, get method ID, and if you have a reference to that class, which in this case we would because it's activity, and of course we have an activity associated with our code, and we can call the take key events method using call void method. Very, very easy, very straightforward, and it's very well documented. So, using Eclipse, not quite as straightforward, not quite as well documented, not quite as well supported, but you can. If you install the C developer tools into Eclipse, install the NDK, then you can do this wacky thing. You can select File, New, Other, C and C++. Now, you're not creating a new file. All you're doing is you're taking your project and converting it to a C and C++ project, which also does not do what it says it does. It actually makes your project a dual Java and C, project, which is cool. So now you'll actually do stuff. Like when you're editing your C and C++ code, you'll actually see it warn you that you've done something that doesn't compile. And you can actually use some of the sense features that are built into Eclipse. Kind of awesome. While in the native code, that's associated with your Java code. Okay? And then you can even make it auto-build from within Eclipse. In another thing that doesn't make sense in the user interface, under configure build path, you can actually set the build command to NDK build. So it's totally possible. Debugging with the NDK. So I have some bad news. First of all, it requires Froyo. Secondly, it only works on the main application thread. So my apologies to anyone who has tried to do this on a multi-threaded application. You'll find out that your breakpoints don't get set. So I'm very sorry. Unfortunately, because of platform limitations, the GDB server is actually built single-threaded. Also, there's no built-in integration with Eclipse, so I hope you like using command line tools. Again, hardcore programmers know how to use the command line version of GDB even if we hate it. And I personally hate it. You can actually integrate it with Eclipse. It's not that hard. Eclipse, the GDB server supports something called MI, which is a machine interface. And you actually can set up Eclipse to do that. I'm not going to go through the instructions to do that because they are convoluted. But the instructions are there out on the web, and I recommend hunting them down. Someday I hope to write a blog post about it because it's definitely a whole nother thing. And so what you do is you take advantage of setting breakpoints within the Dalvik code. And of course, you have debug log messages. That's one of the classes that I told you about, and you're going to want to use those a lot. That's pretty much how I've debugged 95% of my code that's in NDK. So accessing assets natively. Everyone asks me, what's the best way to do this? And there are so many methods out there on the web that tell you how to access assets natively. Some of them are really bad because they rely on unpublished APIs. Don't use unpublished APIs because that means we're not going to support them. And that makes everyone look bad. It makes us look bad because the next version of Android comes out and our compatibility guy comes to me. It's Dan Morrill. I'm sure you've seen him. And he says, Dan, we're both Dans. It's kind of confusing. But Dan, these applications don't run, and I want you to track these people down and find out why. So it gives me a lot of work to do. So our compatibility people hate it when people do that, so don't do it. But here's a way that is going to work for at least the next couple releases of Android. What you can do is inside of Java, you can get access to an asset file descriptor. And an asset file descriptor only works on uncompressed assets. But that's OK. That's probably what you're going to want to use. You're probably going to want to use images and sounds. And you're probably going to want to leave those uncompressed. The other advantage of leaving them uncompressed is they can get really, really big. Compressed assets are limited to 1 megabyte because it needs this huge, huge buffer in order to decompress them. So lots of reasons to use uncompressed assets. You get to read the offset and the length from that file descriptor. You can get the APK file name, and then you just open it up within native code, move it to that offset, and read that length. That's it. You've now read your asset from within native code. You don't have to pass buffers across to Java or do anything crazy like that. Pretty simple. Resources. This question actually came up in Munich. This wasn't originally part of my presentation, and someone said, hey, you're in Europe, and a lot of people aren't internationalizing applications, and it really sucks when I get Android Market and I pull it up and I see nothing in my native language. Does anyone else think that sucks, by the way? Just like, show of hands, like when they pull up Android Market and everything shows up in English. Does anyone not like that? Is anyone understanding what I'm saying up here? OK, that's good. I don't like it. So internationalization is obviously important. And there's no way from within native code to directly access internationalization. But there's a pretty cool way to indirectly access it. And that is using that java-h.jni tool. Once again, you can run it on the generated .r class files. And what's cool is one of the things the JNI tool will do is it'll take all of these static final ints and turn them into hash defines for your C code. So you can directly call JNI to get your strings out. And like this, and it looks kind of, admittedly, it's an internal class, and so it's like this long com example plasma r string resource string blah, but it's whatever. It works, okay? You can directly get your strings that way. And the guy in Munich's like, all right, this is good, but not good enough. I want it to work within Eclipse. I'm like, okay, all right, so how do you do it within Eclipse, okay? This is pretty easy. You can do this for all sorts of stuff in Eclipse if you haven't. You can create a new builder, okay? So this is all I do is I call the tool from the working directory, my JNI working directory, so it generates the files in the right place. And I simply call java-h, and I pass it my .r file. And I tell it that I want to run this builder whenever the gen directory changes. So it's very easy to do that. And it's also good to set Eclipse to automatically reload your files if you do this, because otherwise it's kind of annoying. And 10 more points to anyone who's paying attention. Is anyone out there paying attention? All right, good. I like that. It's hard, I know. I speak really fast. If someone wants me to slow down, just let me know and I'll slow down. But I have a tendency to talk fast when I'm up on the stage. So, all right. Has everyone got that? Good? All right. So, what do we include in the NDK? Well, we include this really cool demo called the San Angeles demo. Now, this was written for a 4K demo competition, okay, by a Finnish guy. The guy who wrote this is the same guy who wrote the game Zenbound. So email him and tell him you want Zenbound on Android. But he did help us out with this. And this demo was originally 4 kilobytes on the PC, and it's now about 400K on Android. So you see we've done really well in shrinking it to bring it to mobile. And it looks like this. Very, very straightforward. It is the simplest possible application you can write. Part of the reason it is so simple is it doesn't actually handle things like application lifecycle correctly at all. This is a terrible example in that sense. But it's a basic thing that shows you how to do stuff. Okay, you'll notice if you hit the home key, the application does the wrong stuff, and if you hit the back key, if you rotate the display, if it just does everything wrong, but it works, okay? But again, don't use this as a model, say you're done, because you're not done here, okay? So what do you get? You have an activity that contains a GL surface view, and it contains a GL surface view renderer. Now, one of the really cool things about a GL surface view renderer is that it creates a thread for you. It assumes, it says, you know what, I know that you're a hardcore engineer, and you want to run your GL code as fast as you possibly can to make it as smooth as possible for everyone who's playing your game. So we're going to create it in another thread for you automatically and just call it as fast as we can and handle that all for you. What that does mean is that any UI calls that you make to the window manager or something like that from within the renderer have to be wrapped because they are in another thread. So I've shown this by this dotted line to show that those are in 2 separate threads. Those are both calling in to the San Angeles code. In actual code, so yes, I'm showing some actual code finally. It's time. This is all this looks like. It's really, really simple. A renderer contains 3 functions. On surface created, on changed, and on draw frame. We have 3 calls that are native. There's a 4th call. You notice it's not used, but I'm sure we'll use it someday. When we actually make the application support the lifecycle correctly. But yes, init, resize, and render. And you see, we just declare them with the native keyword. And then we can call them. And then, what does this look like? Well, here's one example. I'm not going to show you the whole file. But here's probably the most important. Here's the one that actually renders the screen. And I like this one because of 2 things. One is you get to see what the calling convention looks like. So this was generated from a header file. So with Java _com _example blah for a native render. And it also shows an application doing something smart. They want to make sure that the application runs at the same speed no matter what device it's running on. So rather than just trying to run as many frames as it can, it's actually basing everything off of time. So this is important because, as it turns out, Android devices have different hardware. And there, believe it or not, have been some games on the Android market that ran way too fast on some devices. I mean, a lot of them, yes, will run too slowly on some devices, and there's some things we can do about that. We'll talk about that a little bit. But as it turns out, not everyone does this, so this is important, so I like showing this. But then it's very simple. App render just does this, and what's so cool is that the GL context is automatically shared between Dalvik and native code. So even though our GL surface, you did all that cool stuff of calling the EGL stuff that no one wants to learn because it's a big pain, it does all that for you. It sets up the correct native surface for your application. So all you have to do is actually define your geometry, define your camera, all that stuff done inside of C code. Doesn't have to know anything. It doesn't even know that it's actually running inside of a Dalvik virtual machine. All right, so I wish I could actually show this to you, but I can't. But I'll show you a picture of it. Chris Pruitt, who wrote a game for Android called Replica Island. Has anyone played Replica Island out there? Yeah, I love Replica Island. I'm a huge, huge Replica Island fan. I have beaten the game with all 3 endings, and there are 3 endings, and it takes a really long time to do that. But when you're traveling a lot, you also have time to do things like get like gold star every level on Angry Birds. So this is he's been working with O3D, which is a 3D engine we built on top of Chrome. And he's been writing a little game demo. So this is his game demo, and I'm mostly showing this to show a more complicated, what I call hybrid project. And this is another really cool way of using the NDK. So basically, instead of having everything sitting inside of the C code, he actually has the game logic sitting inside of Java, and he's just using the C code to do the complicated geometry transforms. So it handles things like moving objects around. He just says, move this object here and move this object here. The C++ engine does that. The Java code handles everything else, which is great. So it can talk to sound. It can talk to the web. It can do all this stuff and just let the C code do what it's good at. So I like this design. This is not the most portable design, but it is a great design. It's probably the best design use of the NDK around Android. All right. So I'm going to talk a little bit about games. Now, this I know is an NDK session, but at the same time, games are my passion, and well, you know, part of my passion. And so I like talking about the things that people have, problems that people run into when they're writing games on Android. Now, how many people out there have played the beta version of Angry Birds on Android? Couple of people out there. Now, did anyone have that beta version crash on them? No? Okay, no one did. Well, some people did have the beta version of Angry Birds crash. And the reason, oh wait, hold on. This is a different slide. Oh, okay, this is the first thing you should know. I'll talk about Angry Birds later. When you come in from a, you know, this is why I'm just getting ahead of myself is bad. All right, so I'm not even looking at my slides. I'm just like going off here, talking about Angry Birds and Replica Island. And so when your OpenGL application returns from a pause state, your application is most likely going to lose the OpenGL context. If you use a GL surface view, it's going to lose the context for sure, because the GL surface view tries to help you out. It tries to help the Android framework out, and it says, oh, well, someone's hit the pause key, or other applications come to the foreground, and to make sure to give the system as much resources as we can, I'm going to jettison all of your textures and all of your context and leave you to rebuild it. So that's really great unless you're trying to just flip out of your game to check email and flip back in, and you're waiting 20 seconds while it reloads all of your textures. So you don't have to do this. Replica Island actually includes source code for their own GL surface view that actually looks at the EGL get error to determine whether or not the context was actually lost. So you can decide whether or not to reload your textures. It's an option. But the key thing is, regardless of whether you use his GL surface view or the real GL surface view, you're going to have to reload your textures because Android is a multitasking system. And there's a good chance that the person left your application and went and ran Angry Birds, and it sucked all of the system resources dry, and it killed your application off, and it unloaded all of the textures, and then you came back, and your application only had a little bit of state left. So your application needs to know how to recover from that, regardless of how your application is coded. All right, this is the Angry Birds scenario. The right slide with the droid copter. I kind of like the droid copter, actually. He's one of my favorites. Very warlike droids we have here. So my application is inconsistent crashes. The demo version of Angry Birds shipped with this bug. And they mostly saw it in Froyo devices. So if you were running Eclair, you probably didn't see this. If you were running Android 1.5 or 1.6, you certainly didn't see this, although I'm not sure the game runs very well on those devices yet. But basically what ended up happening is they had two threads, and they decided to share a JNI context between those threads. And so sometimes a race condition would happen, where they would try to allocate something in one, and then they would release it because they were being good. They were doing the right thing and releasing their hold on the object. And then the other thread would try to access that same object in that same context, and boom. Dalvik gave this great and completely useless stack trace. And they're like, Dalvik virtual machine is broken. And I'm like, no. Dalvik virtual machine, I know the guy who wrote the Dalvik virtual machine, okay? Trust me, it's not that broken. It's your code that's doing this. They didn't believe me. for a long time, but we eventually did figure out it was actually their code. So use a different JNI context for each thread. It's very important, and it will save you lots and lots of pain. OK, common problems. My game runs really slowly on older Android hardware. What do I do? One, use 16-bit textures. It's actually really easy to do. You can actually use the system to create the textures on the fly, or you can by either on load or on copy. I'm showing on copy here. It's even better to do it on load. If fill rate is a concern, which it often is on these slower devices, excuse me, I'm still recovering from the death flu earlier. You can draw to a smaller surface, and you can let the platform scale for you, which is kind of cool. So you can let it do the work. Now, this only works with surface views, but you can actually use this from Canvas or from OpenGL. Finally, the chipset manufacturers really, really want your games to perform well on their chips. Qualcomm has spent a lot of money, and they want to make sure that their game runs well on their device. PowerVR, Imagination Technologies have spent lots of money, and they want to make sure that your game runs well on their hardware. So they've built tools to help you optimize. NVIDIA has built a fabulous tool. So definitely consider using these tools, because they will help you optimize your OpenGL code. All right, so you've done all of this. My game still runs too slowly on older Android hardware. All right, so I know you people with older devices are going to be like, don't tell them to do this. But don't make your applications run on hardware that it can't run on. There are ways you can filter it using Android Market, and here are two of them. One of them is to filter by GL version. The other one is to filter by CPU version. Now, by GL version is just an entry in the manifest. Even if you're not using OpenGL 2, you can still put it in there. CPU version, you just only build an ARM7 binary. And Android Market will be smart. It'll say, oh, well, you don't support Android, ARM5 devices, and it won't have your app show up for those devices. This avoids the one-star review on Android Market. It crashes on my cyanogen modified G1. Ooh, I hate when people do that. You're running a cyanogen-modified G1. You have no right to give anyone a one-star review, okay? You're running a device that no one has tested and is not compatible. No one should expect the game to run well on it. This is the kind of thing to discuss in forums, not on Android Market. But I digress. So, common problems. My game was built by insert, proprietary texture format. One of the really awesome things about Android is we encourage hardware innovation. This is another way of saying that we don't all have the same hardware and we don't all support the same texture formats. So if you want to have the highest possible performance in your game, you're going to have a couple of different pipelines to generate PVRTC and ATITC and even DirectX texture compression pipelines, okay? So there are some solutions to this if you're not that concerned about getting every last frame. One is that almost all of these cards are going to support ETC1. Now, ETC1 is not the greatest format in the world, and it does not support alpha. But if you use ETC1 along with using some judicious use of PNGs, a lot of games, that's good enough. Another thing you can do is build an asset server. And this is a great use of App Engine, because App Engine allows you to serve lots of bandwidth really cheaply. So go to the App Engine session and learn how to do it, because it's really cool, and you can use it with your Android app. And I'd love for someone to actually write some really cool asset server and client code and make it open source and put a project on code.google.com, and I'll twit all about it, and you'll be cool because well, actually you won't be that cool. I'll be twitting about it. It's like that's not cool at all. But come on, we give you the tools. It's great. Okay. Definitely consider doing that. So things to consider when you're writing your game. Now we're totally off of NDK. This is just pure gaming right here. But here's another Angry Birds thing. You're in the middle of the game, and you're like, I want to go have some pizza. I want to go have some beer. I want to go have some sauerkraut and some dumplings, and I know this is what I do when I'm in Prague. You guys are probably like, I go to McDonald's. But in any case, so you want to leave the game, and you hit the back key, and you're in the middle of the game, and it does nothing. It just buzzes at you. You're like, what? You're like, no, the back key. That's how you get out of things, right? Doesn't work. They said, no. We don't think you Android guys, we're not going to support your UI features. We're going to piss you off whenever you try to leave our game. Okay? So the answer is support regular UI features. Make sure the back key does something. It can bring up a dialog. Just make it do something. Don't make it do nothing. Let volume keys through. Use the set volume control stream within the audio manager. And finally, the home key does not quit your application. We are a multitasking operating system, which is awesome, which means that when the home key gets pressed and the user comes back, they expect the game to still be in progress. And it really sucks if you hit the home key, which you can do accidentally, and you come back and you're like, no, it's gone. Hours of work and pain gone. I've got to spend hours playing games again. Oh, well. It's not that terrible, but it's still really annoying. So my wish list for games. Here's things that I wish people would do when they're putting games on Android Market. One is I would love to see someone actually make games that are small to start with and then download in pieces. Because no one likes waiting for an hour to get the game. They're like, I've got a flight to catch, I've got to go do other things, there's this pizza sitting waiting here for me. Start small. Not to mention, a lot of people aren't always in a place where they can download large amounts of stuff. Sometimes you actually pay for downloads. Use it backup and restore for saved games. If you looked at what's new in Froyo, one of the coolest things that we did is we actually support the ability for an application to back up stuff onto Android Market. And then if you lose your phone or you upgrade to a new phone, Android Market will automatically put your game and the backups on there. So you get to see all of those levels that you spent hours 3-starring show up on your new phone. No one is doing this, and I want to see someone do it because it's cool, because you can. It's free. Supporting multiple control schemes. Not everyone plays the game the same. Some people have trackballs. Some people might have keyboards. Some people might have really, really cool apparatus set up to their, to their phone. Take advantage of it. It's awesome. The more you take advantage of it, the happier your users are, the better your star ratings are, the more people download your application, the more fame you get on Twitter. It's awesome. Use intents. Okay? One of the coolest things about Android, and you'll hear Reto talk about this, and you'll hear Justin talking about this, and you'll hear Roman talking about this, is work with other applications. I have yet to see an Android app that allows me to take a picture of my crowning achievement of causing the most destruction to the green pigs. and take a picture of that achievement and sending it off on Facebook so that everyone knows what an extreme geek I am. So support it. Installing to SD. It's the best way to get 1 star in the Android market is to not support install to SD. Now, a couple people say, but I want copy protection. Well, if you really need copy protection, I recommend using license server, because it's there for you on Android Market. It is much, much better than just checking the copy protection flag. It doesn't do what regular copy protection does, which is actually make your application bigger. So not only does it's like doubly pissing people off, because not only is there this copy protection flag, and so you can't install to SD, but your application actually gets bigger because of the way it works. And you can't support install to SD. And then finally, if you use the copy protection that's built into Android Market, a lot of people will never see your game. Because despite what I said about Cyanogen, a lot of people use it for things like Sim Toolkit. And so if you want those people to be able to buy your game, you can't use copy protection, because as soon as you modify the build and change the build fingerprint, those apps stop showing up. So there's a lot of reasons to not use the built-in protection, use license server, support install to SD. So here's something I'd love to see someone do. Profiling. We have all of these pieces of hardware that support all sorts of cool stuff, and I have yet to see a game come up and say, hey, wait for a second while I profile your device so I can choose the best settings so I can make the game run rocking on your phone. Because devices are just getting faster. They're not getting slower. There's more and more cool stuff coming out. So allow your game to take advantage of that cool stuff. Social. Free advertising. You know, it's almost nothing to add social hooks to your game. allow people to publish their scores. Live wallpapers. Now, this is kind of, you say, live wallpapers don't get along with install to SD perfectly. Still, I would love to see some people do live wallpapers and widgets with their games. Analytics. Okay, one thing that people don't know about Android Market, and I'm giving you a lot here, I know, it's nothing to do with NDK. You can give me really bad feedback. Dan spent 10 minutes talking about stuff had nothing to do with NDK, and I came here to learn about it, sorry. But consider analytics, because analytics are really cool. You can actually set up different referrer links to your application on Android Market and find out whether a blog post or a twit or a Facebook link was actually how they downloaded your application. And then when you're in your application, you can find out how they're using it by taking advantage of analytics. And you don't have to use our analytics. You can use Flurry. You can use someone else. Just use it. It's really cool, and it's out there. And it'll help you learn how people use your application. And then finally, watch your feedback. You don't have to respond to those people who are using the cyanogen and giving you 1 star. But watch your feedback, because you can learn a lot from your users. And that's it. So again, your opinion matters. If you like this session, write about it. If you didn't like this session, write about it anyways. So I'll come back with something better. And you can follow us. Okay, goog.eurodev, GDD, And finally, there's my Twitter link, and there's a link to the NDK. And of course, one more of these. So thank you very much, and I'm now open for questions. All right, so I ask that you try to find a microphone, or you can come and grab this microphone if there isn't one out there, so that other people can hear your questions, or I can just repeat them really loudly. Hello? It is working? Yes, good. So does anyone want a microphone? I can walk through. We're doing this very manually here. Pass this around.
Hi. I have a question about NDK and the strings. Is it actually reasonable to send large strings like 50 kilobytes to NDK? And is there some good way to do this?
So, I mean, the good news, so the question is about strings and the NDK. And the good news is that strings are just another Java object inside of the NDK that you can get access to. And I guess the real question is, what are you trying to do? If you're using that as a method of passing large amounts of data between the NDK and Java, that's not necessarily the fastest way of doing it, but it certainly works. And certainly you can use them within there. If what you do is then call Java functions, then it's fine, because all you're doing is basically passing references across the border. If you're unwrapping the string and you're doing stuff with it, well, then you're running into the same penalties as if you were doing that in Java. It's not a big deal. Either way, it's going to work fine. It's going to work as well as if you were doing it in Java. That's what I would say. But there's a lot of good string functions that are built into JNI.h. So yeah, if that works for you, then I say use it. Anyone else with any questions? Come on, there's a lot of stuff I brought up here. Over there, and if you could pass the mic over and help us out, that would be great.
What's your favorite game, except for the Angry Birds, of course?
I work with so many fantastic game developers. I don't really like naming favorites. I probably have actually, believe it or not, spent more time playing Replica Island than any other game on Android, but that's partially because I helped Chris work on it a little, and so I really got a chance to really play through it. But I mean, there are a lot of really wonderful games now on Android Market, and so I definitely recommend taking a look at everything from Fruit Ninja to Angry Birds to Flick Kick, football. I mean, there are so many great games now that are coming over. It's exciting. It's exciting to be doing this, honestly. And honestly, the new version of Tetris is pretty awesome. I know it's Tetris, but it's still pretty awesome. So, yeah.
or do you recommend still supporting older standards?
So I would say kind of depends on what your target audience is right now. So the question is, if you're developing a game today, would you feel good, and you were starting today, would you feel good about just targeting OpenGL ES 2.0? And I think if what you're trying to do is sell the game, make it a paid game, then that's probably a reasonable thing to do. Because most of the people who actually buy games are the people who have awesome hardware. So it makes sense if you're trying to make a high-end game, you're going to get people who are going to buy it with high-end hardware because they just want to have cool stuff running on their high-end hardware. So I don't think you lose that much for a paid game. If what you're trying to do is a free game, you're trying to get the biggest market possible, then going for OpenGL 1.1 is still a decent idea. But definitely, I don't think there's that much of a penalty with a paid game today. I know a lot of people in the audience are like, but wait, my phone doesn't support. I know, I'm sorry. So go on.
Hello. I have questions to debugging in multi-threading environment.
Yeah.
You said that you can debug only on main thread.
If you use user mode debugging. Now, you can, if you have a rooted device, and no one here has a rooted device, right? But if you have a rooted device, then you can actually run GDB server as root, which is a pretty large security risk in theory, but in practice, it's your own device, So you can do that, and you can do multi-threaded debugging that way, as long as you're running GDB server as root. You cannot use the built-in in-process debugging that's built into Froyo, because that does not support multi-threading. I'm hoping that in a future version of Android, we will fix that soon. But right now, we're still stuck with what we have today.
Yeah, thanks. That's what I wanted to hear.
So, anything else?
White string support.
Wait, so sorry, hold on.
White string support.
Wide string support. Ah, yes, everyone wants this. So I mentioned libc, and as I should have probably said, it's most of libc. It's actually Bionic. And Bionic is a port of the libc from BSD minus a few things that the Android team thought was unnecessary. Unfortunately, one of the things that got jettisoned was wide string support. So what you can do on that, the best thing you can do is use one of the solutions that people have put out in the net for bringing those applications that absolutely require wide strings over. And I know it's not the greatest solution, but they were trying to make things really small, and that gets loaded into every process. So they were they thought, well, we're on a mobile device, yeah, whatever. So unfortunately, that's one of the limitations. So sorry about that. I apologize for the Android team, but I'm sure they had a good reason for it at the time. Again, the devices had very small memory when we started out. Anyone else? And it doesn't have to be about NDK. I work with games. I work with the framework. You can ask me questions about Gingerbread that I can't answer. Yeah.
Are Google planning to release some SDK for game developers?
For game developers. Are we planning to specifically target game developers with an SDK? If we were, I couldn't tell you about it. I want you to know, personally, I would like it. What I want to see, and this is just me talking about what I want, is emulator support for OpenGL. That would be really, really cool, among other things. The good news is that even though we aren't directly releasing an SDK for game developers, a lot of people have taken up the charge. So right now, you have Unity 3D, you have Shiva 3D, you have free tools like NDK for 2D games, pretty awesome stuff. I definitely recommend checking it out. The Corona SDK from Ansco Mobile, AirPlay SDK from IdeaWorks. These are all, some of them are Android specific, a lot of them are cross-platform, and they're all really cool and rich and powerful. Honestly, I don't think anything we're going to come up with is going to be better than those guys. They've done such great work. So I definitely recommend looking at what's out there. And I'm sure there's stuff that I haven't covered in that brief paragraph. So don't be offended if I haven't mentioned your game engine. And if you have something, tweet it to me and say, Dan didn't mention my game engine, and I feel horribly offended, so that I'll know about it. Because there's a lot of great stuff going on. I mean, one thing I love about Android is it's open source, and so many people have taken up the charge and written awesome stuff and open sourced it. And for me, it's like, how did that application work? And then being able to actually go and pull it open and look at the source is just awesome. So I'm really thrilled that a lot of people are bringing great tools to Android under that same banner. So yes, we don't have anything that I know of, but there's a lot of really cool stuff coming. Now that being said, game development is very, very important to Google, and what we announced at Google I/O, if you missed it, is that we are going to support a version of OpenSLES for audio in an upcoming release of Android through native code. So, and I would not be surprised if you would see other low-level APIs as well. But again, the only thing we've publicly talked about is OpenSLES. So we will be supporting low-latency audio, and that's going to be awesome, and directly through native code. Again, not a games toolkit, but better low-level support so that the people who are building the games toolkit can make better games. So I would say that's where we're trying to make sure the framework is there. Mm-hmm.
Hi, great session, by the way.
Oh, thank you.
I've got me and my friend are working on a simple game, and one of the problems we have, well, it's not a problem, but we've noticed that garbage collection can be a problem in games, and currently we have the most garbage collection happens when we check for collisions. It's a 2D game. It's just arrows flying and enemies.
Right.
So my question is, what kind of garbage collection happens, or is there any garbage collection, or how does the NDK or code in the NDK handle garbage, or how does that work? Would it be a benefit if we used like some library in native code to check collisions?
So the thing with garbage collection is that ultimately garbage collection happens when you're doing allocation, and so the primary goal of any game engine on Android is to be paranoid about allocating any objects, and this includes places in which you don't expect objects to get allocated, like even log messages do allocations. So when you're thinking about the core of your game engine, try to make sure that you never create any objects if you're working in Java, because you will guarantee that you'll get hit by garbage collection. And that means, sometimes, 100 millisecond delay or more. And that's really noticeable when you're playing the game. So definitely think about that when you're designing your engine. Now, the nice thing about working in NDK is that we don't do anything for you. So you don't have to worry about garbage collection because we don't do any allocation or deallocation or anything. You get to do that all yourself. And so you're guaranteed not to have any problems with garbage collection as long as you're not allocating Java objects. And so that's one nice thing about NDK. Unfortunately, you have to also manage all of your own allocation and deallocation. And if you don't do it right and you start sucking up too much memory, the Android framework will go blam and kill your application. And so it's something that I talked about. With great power comes great responsibility. That's another one. So we're actually out of time. I know the next speaker is probably coming. Oh, you actually have a break. So you actually get to go out. Hopefully there's something out there for you. But I'll take questions. I'll be out in the meeting rooms, and it's been great getting to meet you all. And yeah, come up and say hello. Thank you.